So we are going to get started. Hello and welcome. My name is Diana Bogan, and I am a faculty development and coaching specialist in the Faculty Affairs Department at UAGC. I will be the host of this session, the Alpha Level Gender Algebra II Grades Pedagogical Environment and undergraduate students enrolled in science, technology, engineering, and mathematics disciplines. By joining us today, you acknowledge that this session is being recorded and will be shared with TLC-related materials. Microphones will be muted for this presentation, but we encourage you to post questions and comments in the chat. We have also enabled live transcription. If you would like to use it, click the live transcription button at the bottom of your Zoom window. Now, I'm pleased to introduce you to Dr. Winnifred Johnson-Carr. She recently defended her dissertation successfully with UAGC, so congratulations, Dr. Johnson-Carr, and she's going to share that research with us today. So go ahead, and it's all yours.
My dissertation was successfully defended. And the title is The Alpha Value, Gender, Algebra II Grades, Pedagogical Environment, and Undergraduate Students enrolled in Science, Technology, Engineering, and Mathematics discipline. Who are you? I am an educator who has a PhD in education. I have several licenses in teaching, and I have used them for developing curricular, learning, assessment, and professional development for teachers to assess and teach students. I aim to teach at a college or university, and I'm eager to get a faculty profession. Research questions and hypothesis, null hypothesis. Is there a significant relationship between undergraduate students, Algebra II grades, gender, and scores on the self-directed learning readiness scale? Hypothesis, null hypothesis. There is no significant relationship between undergraduate students, Algebra II grades, gender, and scores on the self-directed learning readiness scale. Alternative hypothesis. There is a significant relationship between undergraduate students' Algebra II grades, gender, and scores on the self-directed learning readiness scale. Reasons for this title. The researcher anticipated a rejection of the null hypothesis. The quantitative ordinal multiple regression data, which measures a relationship between the outcome and predictive variables, failed to indicate reasons for the title. The researcher anticipated a rejection of the null hypothesis. The quantitative ordinal multiple regression data, which measures a relationship between the outcome and predictive variables, failed to indicate the expected data. The alpha value exceeded the identified p-value as shown by the analysis. Small samples negatively impacted the statistical significance of the alpha value because there was not enough power for the 0.05 level of significance. Participants may not have written their accurate Algebra II grades, which did not indicate a significant difference between gender and Algebra II grades after the analysis. Showcasing the dissertation. The quantitative ordinal multiple regression dissertation focused on STEM, science, technology, engineering, and mathematics. The literature discussed that male undergraduate students had more superb mathematics skills than females, and there was no gender gap. The undergraduate students did not require self-directed learning to strengthen core skills or reinforce a need to request learning assistance from professors. Purpose of the study. The purpose of this quantitative ordinal multiple regression study was to investigate whether gender and the subscales of the self-directed learning readiness scale, that is, self-management, desire for learning, and self-control, predicted Algebra II grades among undergraduate students enrolled in STEM mathematics and mathematics-related courses based on Fisher and King. The results may have a significant effect on the development of the curriculum and assessment in K-12 students' technology, engineering, and mathematics program. Educators and researchers will understand whether gender and the perceived subscales of self-directed learning readiness scales are associated to any degree with Algebra II grades based on Fisher and King. Methodology. The quantitative approach in this study was an ordinal multiple regression, a technique used to evaluate the relationship between one outcome variable and several predictive variables. Ordinal regression was chosen over linear regression since the outcome variable and most predictive variables were ordinally linked, ordinal rank, not interval ratio rank. The question concerned the degree of relationship between variables, specifically whether the regression equation provided a higher than chance prediction of undergraduate mathematics grades based on students' gender as measured by the self-directed learning readiness scale based on Fisher and King. In fact, for a reliable predictor of the dependent or criterion variable, predictive variables should be highly correlated with the criterion variable and have low correlation with each other based on Tabachnik and Fidel. Theory utilized. This study could not identify a relation between self-directed learning and Algebra II grades or between self-directed learning, mathematics skills, and gender. Self-directed learning may have yet to be developed in the curriculum, instruction, learning, and assessment programs of colleges and universities. Students' personalities and academic environment can also impact their ability to achieve degrees based on Casad, Pingenton, and McKellar. Students who exhibit higher levels of neuroticism may not be able to cope with academic stress, which motivates them to seek success based on Earth and Waugh. Conversely, students who scored high on extrinsic motivation often experience less difficulty in their academic program based on Ito and McPherson and Waugh. Female undergraduate students who are not confident in their ability to succeed in the mathematics classroom are more likely to choose non-mathematics related STEM disciplines such as biology based on Amaro and Zaleski and Helix. High overview of the literature. Public Law 114 to 59, also known as the STEM Education Act of 2015, defines STEM education as education in science, technology, engineering, and mathematics, which provides for computer science. The National Science Foundation provides merit-based grants to support and engage individuals in research and school learning development to improve STEM learning outcomes and STEM engagement. Funds can be used to implement single, multiple, or integrative STEM ideas, to design and test STEM learning models, and to develop programs and resources to improve STEM learning outcomes. Data collected. On the demographic form, students provided information about their race, age, and whether they were freshmen, sophomore, juniors, or seniors. The marketing research company recruited male and female participants. Approximately 100 participants were required to control for the possibility of attrition, and surveys required correct completion. Initially, there were 285 participants for the field testing. Upon examination, 215 participants were disqualified, leaving 74. The power requirement was affected and not met because one of the following reasons: the students did not complete the survey, did not have Algebra II grades, did not qualify for the undergraduate STEM major, and did not meet the minimum age and did not meet the research specification. The self-directed learning readiness scale instrument took 30 minutes to complete based on Fisher, and King. Key findings. The statistical assumption for conducting an ordinal multiple regression were met. The chi-square test did not significantly differ between the null hypothesis model and the general model. The goodness of fit test demonstrated that the model, that is, the predicted regression model, did not fit the data. The test of model effects also showed that the outcome variable was not statistically significant with the predictor variable gender. The predicted variable self-directed learning readiness scale also had no statistically significant effect on the outcome variable Algebra II grades based on Fisher, and King. The obtained pseudo R-squares indicated that at best only 0.49%, and the variance was explained by the relationship between gender, self-directed learning readiness scale scores, and Algebra II grades based on Fisher, and King. Given these results, the alternative hypothesis was accepted based on Keith, Laird, Tabachnik, and Fidel. Impact of the findings. A significant lack of fit indicated that the model was not representative of the population and that there was no meaningful practical relationship between Algebra II grades, self-directed learning, and gender variables. Moreover, the test of model effects showed the OV Algebra II grades, the PV gender, and the intercept were not statistically significant. In addition, the PV self-directed learning and the OV Algebra 2 grades did not have a statistically significant effect on the intercept. Therefore, based on findings on the study, there may likely be no relationship between gender, Algebra 2 grades, and self-directed learning. More importantly, it could also be the case that there may be a minimal relationship between these three variables, which would have to be proven in a future study with a much larger sample size. The sample was 74 students assessing the alternative hypothesis. The analysis of the data indicated that the outcome variable Algebra 2 grades and the predicted variable gender were not statistically significant. The PV self-directed learning and the outcome variable Algebra 2 grades failed to indicate a statistically significant effect on the intercept participant of the self-directed learning readiness scale based on Fisher, and King. Next steps. The researcher posted a smaller version of the dissertation as a journal article and awaited a response. What was achieved? The knowledge that the bell curve showed males had higher Algebra 2 grades than females, but the finding did not identify a gender gap in mathematics. Sample size, effect size, and research instrument influence the statistical significance of a quantitative ordinal multiple regression study based on Tabachnik and Fidel and Keith. This study had a small sample size and the effect size was nil. A lack of fit accepting the alternative hypothesis showed that the model did not represent the population. What should others take away from these findings? These 5 visuals have shown that the need to embrace the study of STEM from science, technology, engineering, and mathematics perspective. 10 individualized nations have focused on offering advanced STEM degrees, research, and professions for the continued success of the nation. The United States is a leader of the 10 industrialized nations of STEM. United States, China, United Kingdom, Germany, France, Australia, Singapore, Canada, Netherlands, and Switzerland, based on Global Admissions Review. Why is the information important to the field? The p-value was set at 0.05 for the ordinal multiple regression study. However, there were other factors to consider. Participants reported their Algebra 2 grades, which may not indicate abilities. The scores in the bell curve may not be indicative of mathematics strengths or abilities. Participants responded to the research instrument, which was a 6-point Likert scale questions based on feelings regarding self-management, desire for learning, and self-control of the self-directed learning readiness scale based on Fisher, and King. The responses may reflect bias, since scores range from 150 to 200, and participants scoring lower than 150 were not ready for self-directed learning in college or university based on notes. The researcher did not use random sampling. The sample who volunteered may have overrepresented the actual population. These factors can affect the generalizability of the findings because of sampling error based on Keith. Undergraduate programs by gender. Many undergraduate STEM degree programs have more males than females because males have mathematics confidence. Females tend to lack confidence in mathematics based on Carver. The lack of confidence in mathematics leads to more males than females in physical science courses and careers based on Ellis. Many educators regard females as competent in mathematics as males, but females chose non-STEM careers based on sex. Demographic characteristics, Algebra II grades, gender, males and females. The demographic characteristics, Algebra II grades, and gender report indicated that the lowest score for males was C+, and the lowest score for females was D+. Educators must concentrate on enhancing problem-solving mathematics initiatives for undergraduate enrollment in females. Histogram, bell curve, Algebra II grades. The bell curve showed a higher peak or cluster of scores for males than females on the Algebra II grades, and the spread of scores was from right to left. Males had one outlier or unusual score. Female studies had a wider spread or scores than male students. The far right of the bell curve indicated where the lowest Algebra II scores fell for males and females. Undergraduate program measure, marginal percentage. The data indicated that only 8 undergraduate participants chose mathematics as a major. Science, followed by technology and engineering disciplines, appealed to the sample of 74 participants. Science appealed to most of the participants, followed by technology, but the marginal percentage was not significant. This bar graph showed males had higher Algebra II grades than females, and they had one outlier or unusual scores. Gender and physical science competence. A significantly lower percentage of undergraduate females, that's 17%, and 32% of males who enrolled in science, technology, engineering, and mathematics disciplines negatively impacted professional relationships based on lack of gender competition in the environment based on Ellis and Kim and Sachs. More females can dispute with males professional knowledge, providing a higher level of work-related correlation through suggestions, agreements, and disagreements. These behaviors challenge work-related discussion in engineering and other physical science STEM profession based on Mulek. Thanks for watching and listening.
Johnson. I just want to thank you for that presentation. We have just a couple of minutes. If anyone wants to ask Dr. Johnson-Carr any questions. I have a question, and I just wanted to know what your favorite or the most challenging experience that you had just going through your dissertation and your research. What's your biggest takeaway from this experience?
Before I started the dissertation, I wanted to accept null hypothesis because I was reading about other researchers accepting the null hypothesis. When I started doing the dissertation, because we had such a small sample, originally, when we calculated the sample, we wanted to have more than 100, but based on some of the participants, they were not Zoom undergrad, they were not STEM participants. So we could not abuse them in the sample. So we ended up with just 74 participants. When the sample is small, then we cannot expect the statistical significance to be to reject the null hypothesis, because the statistical significance would not be able to reject the null hypothesis. The statistical significance would not be at 0.05, and we had set the data to be at 0.05. So the statistical significance exceeded 0.05. So we had to accept the alternative hypothesis.
That's really interesting. I'm sure that was kind of also frustrating because you wanted that null hypothesis to be true. You wanted your question to be answered the way you expected.
Well, I know. Yeah, but my chairperson said, no, do not do not worry, because many researchers have to accept the alternative hypothesis, because research studies do not always go the way we think it's going to go.
Nothing ever happens the way we expect it. Well, thank you so much for your presentation. There's some thank yous in the chat that your presentation was greatly appreciated. Thank you to the audience for your participation in today's session. Please use the survey linked in the chat to nominate TLC presentation for conference awards and to share your feedback on your conference experience. The conference awards take place today at 2 p.m. Pacific time, so in about 30 minutes. So be sure that you do all your voting prior to then, and that you join us to celebrate this year's winners and the conference in general. I'm going to put that in the chat now, and please enjoy there's one more set of presentations at 1:30, and then we'll wrap it up with the winners. So have a good day, everybody.